So hello everyone. So in this video I am going to screencast my Leetcode Biweekly contest 118. So find words containing characters. So you are given zero indexed array of words, array of strings words and a character x. Return an array of indices represent word contain the character x, 0 and 1. Okay, so 0102 and blank, 0102 and blank. So the next problem says that maximize area of square hole in grid. So there is a grid with n plus 2 horizontal bars and n plus 2 vertical bars, initially containing 1 into 1 unit cells. The bars are 1 indexed. There are given two integers n and m. You are also given two integer array h bars and v bars. H bars contains distinct horizontal bars in the range 2 to n plus 1. V bars contain distinct vertical bars in the range 2 to m plus 1. You are allowed to remove bars that satisfy any of the following condition. If the horizontal bar, if it is horizontal bar, it must correspond to a value in the vertical bar. If it is vertical bar, it must correspond to a value in vertical bar. Return an integer denoting the maximum area of square shaped hole in a grid after removing. Here n equal to 2 and m equal to 1. So n is horizontal, so n plus 1. Plus 2 should be equal to 4. Yeah, so we have 4 horizontal bars, right? And m equal to 1, so 3 vertical bars. Okay, and h bars equal to 2, 3 and v bars equal to 2. The left image shows the initial grid formed by the bars. The horizontal bars are in the range 1 to 4 and vertical bars in the range 1 to 3. It is allowed to remove horizontal bars 2, 3 and vertical bar 2. So we can remove these two horizontal or these two vertical. One way to get the maximum square shaped hole is by removing the horizontal bar 2 and vertical bar 2. Okay, so here we can remove this and this. Here we can remove 2, 3. I think we should remove all the bars because it will anyhow increase the maximum area. And horizontal bar and vertical bars contain some distinct values, so we'll be removing all the values. And how we can find the area? For finding the area, like initially there will be all these vertical bars. If we remove 2 and 3 and 2, 3, 4, 3, 4 3 2 3 4. Isn't it like we have removed this only, so the horizontal bars are in the range 1 to 4. What is allowed to remove 2 and 3. Vertical are in the range 1 to 5. Vertical bars 2 3 and 4. One way to get maximum skewered is by removing horizontal bars 2 3 and removing bars 3 4. Why we can't remove the vertical bar 2? Oh, we have to generate a square hole. Okay, that was the thing I didn't focus on. So for getting square, if we are removing 3, we can remove, we know all these are removed, and find the area. Suppose some are removed, some are not, the configuration will be this. Now we can find, so 1 2 3 4 5, 1 2 3 4 and 5. So at each position we can find which is the next bar which is the vertical and which is the right bar which is the vertical. After that we can take their multiplication, like for 3 into 2. Yes, max or equal to 0, max var. Initially it is 1. So for int I is equal to 0, I should be less than h bars. So h bars dot size minus 1 plus plus. We have to see continuous. So if we have 1 2 and it is in increasing length or what, sort h bars we have 1 3 4 5 6 9 10. So initially it is 1. If it is same it will be 2. If it is not same it will be 1. So if we h bars of I equal to h bars of I minus 1, then count plus plus, else count equal to 1 and max x or equal to max of maximum of max or count similarly for int j. Int I is equal to 0, I should be less than v bars dot size I plus plus. Now if hv bars of I equal to v bars of I minus 1, count equal to 1, count plus plus, else count equal to 1, max or max var equal to maximum of max var or count, and we will return mini is equal to minimum of max or max var. Return mini into mini. one. So we have max or max equal to 1, and it is sorted in increasing order. Now is equal to plus 1 plus 1, 114. So we have 2, 3, initial is 1, so now it will become 2. Four, 9. So we got accepted. Moving on to what is this? Minimum number of coins for fruits. You are at a fruit market with different types of exotic fruit on display. You are given one index array prices where prices of I denotes the number of coins needed to purchase the ith fruit. The fruit market has the following offer. If you purchase the ith fruit at the price of I, you can get the next I fruit for free. Note that even if you take the fruit J for free, you can still purchase it for price J to receive the new offer. Return the minimum number of coins needed to acquire all the fruits. Okay, so length is n cube, like n is up to 1000, which gives idea of dp. So at every point we have two options, either to take it or not take it. So let us suppose dp of I comma j, if we write a recurrence relation, it will be something like firstly I will be there, and if we take it like what I am saying, that maxi will be equal to, if there is two options, if we take it, so it will be nothing but maximum of recurrence of I plus 1, and if we take, so minimum coins. So if it, so maxi is minimum of, if we purchase it, so it will be purchase it if v of I plus rec of, if we purchase it, we will get this in free. We can go to here or we can go to here. So let us write the recurrence relation. So int or long rec int I vector int prices, and int if I equal to prices dot size return 0. Now we have two options, and mini is equal to minimum of, if we take it, so prices of I plus, we can go to one step or we can go two steps. So rec of I plus 1 prices, or prices of I plus rec of I plus 2 comma prices. and return mini. But it will be of exponential to the power. That's how we can make it in a dp. So suppose we have some prices, and if we have dp dot resize rises dot size. Okay. So if we purchase it, we can directly jump to this. Or if we purchase, you have to purchase it the first, right? Next, iFruits is that. Okay, so anyhow we have to purchase the first. Now if we have two options, whether to jump here or jump here.